I got some mail from our Asian friends, and I'm gonna open them. First, the big one. I already know what it is because it actually said so. Power supply, half kilo. They placed a $5 value. I like it. Trying to be careful because for a power supply it's not really packed good. Jeez Louise. Come on baby, you're not gonna win anyway. Just let go. Okay, that was it. No notes, no nothing. I bought this for my 3D printer because of my last one blew up. It was only a 12 volt, rated 12 volts, but I boosted it up to 14 volts to have a little bit more punch for my heated bed. But yeah, it didn't last it. I put the safety guards for this one. So you don't get shocked, because these main wires are just not protected anyway. And when you're poking around in your 3D printers, you probably can touch this. Also printed some extras for this one. I hope they're gonna fit on the other one. It's really simple, because this is placed like this in the bottom of the printer. They're gonna fall plastic down on the power supply. So I printed this protection so nothing can fall in the cooler. I just downloaded it from the thingy first, so everybody can do this. But really handy. And then some clips to hook it up on your printer. I place them like this. I think it was, yeah, I placed them like this. And then I could press them on the bars from the wrap up. Really handy. I think the other one is a little bit bigger, so I don't know if everything's gonna fit right. And then I have to print other. Oh, nice. It has a little bit of protection. Yeah, this one is rated 15 volts. Yeah, it's on 240. But jeez, it's like hanging loose. What the hell? I can put a screwdriver in between. Yeah, I'm gonna need to open this first. Let's check the inside. I picked the 15 volts because my control board is rated up to 16 volts, so I can heat my heat beds a lot faster, I hope, because previously it was 30 minutes plus, easily 30 minutes plus, depending on the conditions. Okay, warranty voids, worthless. Yeah, I think it's 20, even not $20 supply. So they didn't even bother hooking this one up. Just hanging there, resting on the shoulders of these soldering. Everything is corroded. So this one out. That's what you get for such a cheap bend here, probably by transportation. The screws are corroded, like really rusty. There's grease all over the place. Jeez. There's a fuse. So jeez. Yeah. I don't have high hopes for this one, but yeah, well, we'll see. My previous one was a cheap one also, but it seems I opened that one up also because it was broken. I wanted to see if it was just a fuse. But it seemed better quality. I think I paid a little bit more also though. But that's like 3 years ago. But in the end it broke also, so we'll see for this one. I'm not gonna stress this one a lot. I don't wanna overstress it from 12 volt to 24 volts. And probably all the time full power. So this one is gonna be underpowered. gonna check. This still gonna work. Oh yeah, that's nice. Don't get the grip from the corner. No, I just stripped the plastic of the cooler, so I hope it doesn't vibrate too much. I don't really need this anymore, but I built it, so I'm gonna use it. Let's test it. I need 220 cable. I need to check where it is. Okay, I found one. These are the 2 live wires and this is the ground. There we go. Plug it in. hope it doesn't explode. Nope. It works. Wait a moment. Now if you're gonna see this. So up to here, that's the rail for the positive, and that's the rail for the negative. So 3 connections each. Yeah, 15 volts. Just gonna be a rail. No drama here. I am gonna turn it down though. The maximum is 16.4 and the minimum is 10.2. I'm gonna turn it down up to, let's say, 14 exactly. That's underrated quite a bit, eh? Okay. Disconnect the main. Yeah, I need to see where I put this. That is different. They seem different. No. I placed them upside down because actually it is hanging in between the rods from the printer. Right, that's one side. That's the other side. Yeah, it broke off, but it still works. And the fourth one is missing. pushing against any components on the inside. Okay, this is one done. Oh yeah, then I have this one. I ordered these from Hobby King, and they shipped rather nice and fast. I don't know anymore for posting the shipping. Shipping was $14, so yeah, it's quite expensive, but yeah, I needed those. Ah, nice. I thought I ordered 4, not 3. Yeah, I ordered these for my next tricopter project. I made a previous movie about these first engineering plastic brushless motors in the world. These are plastic motors. I already balanced it. The motor itself, not with the screw. These are plastic. I made another movie. I'll link it in down below. I think these are quite nice for 2 reasons. They weigh only 19 grams and they can thrust 290 grams times 3. That's nearly 900 grams. So that's with the 3S battery. So I ordered these speed controllers. They're rated for 2 and 4S. I'm gonna fly with 3S. And they have the firmware from Afro. They have a higher frequency. See? Input frequency 1 kHz. I think the standard firmware ones have 300 Hz. 300 Hz, I think. So it's gonna be a lot more stable. It's only 12 amperage for 3S. That's more than enough. And this is the programmer. So if there is a new firmware, I can actually program them with the new firmware. I don't know how you're gonna connect them. How are you gonna connect them? They said you didn't have to get rid of the crimp sleeve. I think here are the test and programming dots. They don't seem to have the right distance. We're gonna need to read up on this. Or it just does it like this. Possible. Yeah, probably. Yeah, probably. So I don't think this is for the firmware. I think it's just to set up the ESC. I need to read up on this. I thought it was for the new for a new firmware or whatever. But is it so connected then that you can do it through the signal cable and the server cable? Weird. I need to read up on this. Anyway, we're gonna work a read. And then I had two back converters, U-back converters, to have a stable 3.5 amp voltage out, 3.3 voltage out, up to 3.5 amperage. But yeah, that's plenty. To power this one should be the same, 3.3 voltage out. To power the receiver. And the controller board. So, because these ESCs don't have them on board. Most ESCs, the high rated ones, yeah, they have them on board. But now you need another U-back converter. The price was for the ESC $3.5 each. That seemed low. I don't think that's the correct price. You can look it up on OPTO. Okay, this for the Tricom. I think that was the most expensive package. So. Another one from China. Oh, leads. Oh yeah, I had a project in my mind. Yeah, this has nothing to do with it. Yeah, just testing leads. I had a project in mind. Ooh, no, crooked. Where I could switch the light on and off from day to night, from dark to daylight. So I could build this in this waterproof box. It's a waterproof box with the seal in it. So I could switch on the light on and off from daylight to night. That's it. and keep those together. So it's not just plastic threaded, it's actually iron. Nice. The leads for the breadboard. Another one. Oh yeah. There's a cable here. So can cut there. Nice. I wanted this. And this is gonna be fun also. Okay, these are two. I'm gonna leave them packaged. Ultrasonic sensors. I'm gonna use one to test the hell out of it. And the second I'm gonna use on my quadcopter. I can connect it to my Ardu pilot, and then I can make it auto land, because now the auto land is relying on the GPS location, but that's not enough. The GPS location is up to 2 meters, and if it's descending too fast, it can be crashing up to 2 meters into the ground, so that's not enough. These are not quite sensitive. I don't know up to what meters and measurements they work, but I guess they go to up to maximum 4 to 6 meters, maybe. And I guess the optimal distance would be about 1 and 2 meters. They send ultrasonic sounds and they catch it, and they calculate it on the ships behind them, how long that took to send and receive it, so they can measure it. It has a oscillator thingamabout, probably to oscillate the sounds. I'm not that good in electronics, so I leave that to the experts. I just like to play with them. So, ultrasonic measurement devices, modulus. Nice to play with. And then this one. This cost about 80 cents a piece, so about 2, free shipping. This is what I waited for a long time. I read about it, or some YouTube movies about it. I can't grasp my head around it, how this works. I keep it simple. There's one side, that's the cold side, and one side that's the warm side. If you put a cooler on the cold side and you cool it, you can cool it harder than the warm side, then it generates electricity. where I bought it, it says it's up to what was it? 136 watts. But no, I don't believe that. It's probably using 136 watts, and that's the other application, because you can all what I explained a second ago was to uh, make electricity. You can also put electricity in it, and it can cool one side. They use it on those frigo boxes. I don't know the English naming for it, but the boxes you use to take you with you to the beach to keep your food cool. They mostly work on 12 volts for in the car, so you can, and they use Peltier devices to pull the heat out of the frigo box and leave the cold air in and the hot air out. But that's when you put electricity on it. I kinda wanna play with it right now, but this I'm gonna use this to make a whole new movie about it. I'm gonna read up on it, and I'm gonna try to understand the science behind this, because it's really interesting. Because how I now understand it, everybody should put this between his CPU from his computer and his cooler and create electricity. It's probably not much, but the device costs 3.5, $3.50 dollars. So that's about €3. I don't know the lifespan of it, but I think you can make enough electricity to pay back this device. I don't know. Between your cooler and your CPU, I mean. I don't know. I'm gonna use a whole new movie about this. And then there was a kit. I don't know anymore. The starters Uno kit, but it's a fake one. Yeah, USB cable, not micro. Some breadboard leads, but in a cable. And then for the price, it was $5.25. For the price, I couldn't let it go. There's even a small breadboard in it. Cute. Look at all this for $5. About €5. It's $5.25. Yeah. They could work, but they're not happy. They could work. That's the fake Uno. The button here. Probably the LED. Soldering is nice. Don't need to reflow anything, I guess. All sorts of components. Let's do this. Micro switches. Micro? Mini. They're quite big. That's a micro. I think it's just a mini. Nice. Are these heat or light diodes? I think they're light. 9 volts battery clip. Some resistors. LEDs. Yeah, all sorts of things. For €5. I'm gonna have fun with this. Okay, resistors. 10k, 70k. Oh no. 1k. 220k. These are not temperature, I guess. I think those are light relays or diode. I don't know. Throw it away. Yep, gonna have fun with these. And then if this works good, you can buy a real video and start playing with it. That's why the stakes are nice. To learn, destroy it, break it, and learn, and then buy a real one. €5. $5.25. Free shipping. All over the planet. Crazy. Untracked. Oh yeah. No, that's nothing interesting. I just need to keep on buying these because every time I see a friend or a co-worker and they see this, we speak about it, they want it, so I always give mine away. They're cheaper, that helps. But they are actually really nice and pretty good. These are car windscreen GSM holders. Placed on your window of your car. You set it up how you want. And bam! They actually work really nice. I'm gonna look up the price for you. It's crazy. I have to keep on buying this. Now I ordered 4 and I hope you can. Next is, oh yeah, that's for my my device in the car. I always blew those fuses. Now I two spare. Always when you want one, when you need one, you don't have it in your home. Two spare. They're really heavy duty. They're rated for quite high currents. Check the fuse. 250 volts. I think it's 15 amp. It's quite high. Yeah, but I think it's 15 amp. Yeah, with those sheep ones, the spring. When you put a higher current fuse in the cheaper ones, it works. But then the spring is just burning through. This is a more heavy duty spring. So I like it. Yeah. Good. What the hell? Oh yeah, those are lower current ones. With an LED. Yeah, I don't think so. Small one. Let's strip. I think I get the wire. Getting too bad. LED strip. Oh, but they're actually nice silicon. Oh, those are two. And you can actually cut these. They're every okay. They're actually every 3 LEDs. It's about 6 volts, I guess. Probably they are in sync with 3 others. Oh, there is a resistor here. These are rated 12 volts, so I'm gonna put 12 volts on it. This battery is 11 volts. It's gonna work just. Why is this not working? Is this buck converter broken? Is my cable not good? 12 volts. What the? What the? Connected completely wrong. Why did I put the... Okay, let's check this. The input is 12.5. That's not what I measured. No, 12.4. I'm gonna set this voltage on 12 volts exactly. Dum 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 dum. Take your time. And the current, I'm gonna put it on half an amp. Start. No, nothing. 1 amp. Nothing. It is broken. Oh, I don't have output. Okay. Oh. 0.3 amps. Doesn't even draw that much. It draws 0.15 amps at about 12 volts. 0.15 amps. Yeah, okay. Nice. Yeah. 0.05 amps. I can't get this buck converter into constant current modes, in constant voltage modes. Very annoying. 0.14 amps. Zero 0.15. What about 12 amps? That's nice. That's not using a lot of electricity. Okay, put the light back on. Nice. Solder these, yeah, you can solder these on this one. I don't know why they cut it. Why don't they just give me 1 meter? I'm just gonna test the other one if it works. Probably yes. Oh yeah, by the way, I nearly never buy from eBay, mostly from AliExpress, so just so you know. Okay. And also this one is working, but this one is drawing 0.16 amps at 12 volts. A bit more, maybe because it's curved. Yeah, whatever. These LEDs also are for my 3D printer to have some light shining on the heat bed. And this one, the last one, is also LED strip. But I think these ones I ordered for my kitchen. The ones that are hanging now in the kitchen. Those are RGB LEDs, and they are nearly all broken. Some give blue light, some give red light. Okay, that's it. A remote control. Should be remote. Why is there a cable with remote? Oh, nice. We need to plug it in. And I guess this one is the controller. Receiver. Nice. Some finish. This will be the LEDs, this will be the adapter. Let's see. Whoa. That feels really bad. I don't think I'm gonna use this one for my kitchen. Because if you leave it on and you go off to work and you forget about it, I don't think the insurer is gonna be happy with this. This one is a 12 volt 3 amps. No, I don't think I'm gonna trust this one. In the LEDs. These are also RGBs because yeah, I'm used to them. I'm gonna use it just to test with it. Measure the output. 12.5. It's a normal standard plug, so you can use whatever adapter. Alright, here's the receiver. There's an arrow here. I don't know if you can see it. There's a little arrow. And on this there is also a little arrow on the positive side of the controller. So I guess I'm gonna put it in like this. It's already in demo mode. We have the battery protection. No, it's not gonna work. It's not working. There's simply not a battery in it. What? Oh, why did I put the why did I put the plastic in it? There's not a battery in it. What the hell? Okay, I gotta get the battery. Let's pick one. Let's try. No. Damn it. Three volts. It just doesn't work. Oh, now it does. CR 2025. These are CR 2025s, right? Oh, 2032. That should be thicker. The 25 I used before and it wasn't thick enough. I use a thicker one, but it still doesn't work like it should be. No. press the cage, the plastic, to make contact with the battery. White. Okay, I'm gonna turn off the lights again. Yeah, I don't have power. It's all the same. On off. Red. All the reds. It doesn't dim. Yeah, it is. It's really slow. It's the most bright. And you have flash. It should be strobe, but it doesn't do that. Fading. It's probably strobe. Yeah, these markings aren't right. I probably use it just for white. And when visitors, just let that go smooth. Not like this. Like this. But they're really slow. Normally with the brightness and the dimming, you can make it slower or faster. Yeah. Now it's going faster or really slow. Okay, it works partially, but yeah. I wasn't expecting more. It was really cheap. Yeah. Whoa there. Whoa. They're really hot. The price. Van een thermometer. Okay, the price is $7.49.94, so $8 for an RGB LED strip with remote and power supply. It's 44 LEDs. But now I left it on for a while, and they're really getting hot. See, they're 80 degrees. Okay, they're curled up. 88 degrees, 90 degrees. No way. I need to turn it off. 90 degrees. Almost 90 degrees. 91. But they really feel hot also. Jeez Louise. They're near melting point. Oh, you can order another set. Look them through. Here are the soldered together, so I don't know what is those lips. When I touch these, they're not siliconed in. When I touch those resistors, you get an emitting. They're emitting light. Probably not so healthy, so I'm not doing it anymore. Okay, that's for the kitchen. Common note, static red, speed. Nothing special. That's all she wrote. Power supply is not getting hot, so is it safe to use? I don't know. I don't gonna risk it though. It really, I think it, no. It's still hot. That's it. Waiting for the next deliveries. Bye.